Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I'm your teacher, Simi Namer. Hope everything is going well with you and your family. This is my lecture number 5 for grade 7, Geography. And we have to continue with chapter number 2, which is Earth Alive. Earth is the only planet in the universe known to possess life. The planet boasts several million species of life living in habitats ranging from the bottom of the deepest ocean to a few miles into the atmosphere. Not only these changes, dear students, the surface of the earth changes. Some changes are due to slow processes such as erosion and weathering, and some changes are due to rapid processes such as landslides, volcanic eruptions, and earthquakes. That's why we say the earth is alive. In the previous lecture, we learned about the folding process, and I've told you then when two geological forces from opposite direction act on each other, folding of rock layers within the earth crust takes place. The tremendous compressional force exerted on the rock layers by geologic movements causes rock layers to wrap and bend. The amount of force exerted on the rock layers influences the way they bend and crumble. I even explained the structure of fold, and that was when the folding occurs in sedimentary rock, they bend upwards and an anticline is formed. You can see this is anticline and the sides of the anticline is known as limb. And the area that bends downwards, this is called syncline. This is syncline. The area that bends upwards, that is anticline, and both the sides are called limbs. And there is compressional forces that is exerted from this side and from this side. This is the axial plane, which is like an axis, which is an imaginary line. Just to tell you about the this point of anticline. Then we learned about the types of folds. I've told you the amount of force exerted on rock layer influences the way they bend and crumble. So they make different types of folds then. You can see in the symmetrical fold, when the amount of the compressional force, like you can see this arrow, they are showing the compressional forces that is exerted from the both sides. If the force is equal from both the sides, so the rock layer is likely to wrap and crumble to form a symmetrical fold. So the sides of the limbs must be of same size and same shape. When the amount of compressional force exerted on rock layer is unequal, you can see in this fold, you can see there is double forces from this side and single force from this side. So the limb must be steeper from one side and gentler from the other. So when the amount of compressional force is unequal, the force exerted on one side is stronger than the other, so the rock layer will wrap to form an asymmetrical fold. Further uneven compression will cause one limb of the rock layer to be pushed over another. You can see here that one limb of the rock layer to be pushed over the other one to create an overfold. This is a kind of overfold. Over time, the overfold will becomes a recumbent fold. This happens when the axis of the fold becomes almost horizontal. This is the axis, and this is almost horizontal because there are 3 times bigger force than this side. So this will push this one limb and the axis will become almost horizontal. Extreme stress and force can cause the recumbent fold to fracture along a plane of weakness and break, creating a fold. In this example, one limb will cause, this is the side which is called limb. So in this example, you can see that one side of the limb will push over the other. This limb will push over the other. You can see there is 4 times more compression from force from this side. So this limb will push almost this one, and you can see this axis line will almost fracture, creating an overthrust fold. A lap is formed when the stronger compressional force pushes the overthrust fold to move along the fracture line. You can see this is a fracture line, and because of the compressional forces, you can see it pushes the overthrust fold to move along the fracture line. That was all about the previous lecture. Let's start today's topic, which is volcanism, and this is in your book on page number 14. This is the new topic, volcanism. Volcanism is the phenomenon of eruption of molten rock onto the surface of the earth or a solid surface, planet or moon, where lava, volcanic gases erupt through a break in the surface called a vent. This is the process by which materials such as magma and gases from inside the earth are forced onto the earth's surface. This is a part of the process of bringing material from the deep interior of a planet and spilling it forth on the surface. In many cases, eruption build up a pile of material, a mountain, what is called volcano. The cavity in the Earth's crust below the vent that holds magma is magma chamber, from which the magma is forced onto the Earth's surface. It is moving from a passageway which joins the vent to the crater of the volcano. It allows the magma to flow from the vent and then to the crater, and it forms the layers of volcanic material that build up around the vent to form a cone-shaped structure. I've told you that the process through which the magma or the lava that is forced onto the Earth's surface is done through many processes, or we can say this is done in many ways. These different ways are making different types of volcanism. So in your book on page number 14, the first type is underwater volcanism. Let me read from your book and I'll explain everything here. Underwater volcanism takes place at the constructive plate boundary on the ocean floor. You know what is constructive plate boundary? This is the divergent plate margin. Divergent means like when the plates move apart from each other, they are creating gap between the plates. Between the plates, they are creating gap, that is called a margin. So this is the constructive plate boundary. At these boundaries, oceanic plate that move apart, you can see diverge here, move apart, they are moving apart from each other. So they are leaving a rift. Rift is called a crack. Rift means crack or a gap between the plates. The process allowing magma from the mantle to surface through this gap, through the rift as lava. Rift means crack. So this is actually a gap or a crack through which the lava comes to the surface of the earth. when the lava comes into contact with seawater. Obviously, when the lava comes out from the crack or the gap, it will get contact with the seawater. So the hot lava will cool down, it cools and hardens to form crust on the ocean floor at the boundaries of oceanic plate, resulting in sea floor spreading. There is a figure 2.9, seafloor spreading at a constructive plate boundary, and you can see even in the figure that there is a gap between the plate boundaries. This is called the constructive plate or the divergent plate. As the magma seeps through the gaps on the ocean floor, it is sometimes ejected with some pressure. Seeps means when the lava is coming out or this is flowing or leaking from the gaps or from the cracks, it is sometimes ejected. Ejected means discharged with a heavy pressure and causing it to spew upwards to form a ridge. Spew means to emit. So this is the emission of lava that is in such a pressure that is causing a ridge. A ridge is like a mountain. Ridge is a mountain. So when it is the lava is emitting with such a pressure and it is ejecting from the cracks, they are making ridges. The world's underwater ridges and volcanic islands were formed as a result of underwater volcanism. Many of these mid-oceanic ridges have formed underwater volcano systems which can stretch for more than 65,000 kilometers around the world under the ocean. These systems can be even longer than the fold mountain ranges on land. Some of the tops of underwater volcanoes have even emerged out of the sea as islands. So when they are spinning upwards and they are making ridges, and when this hot magma are getting contact with sea water, so they are making crustal floors, we can say ridges, which is also called islands. Some of them are ejecting with high pressure and they are even coming from the surface of the water. They are coming out from the surface of the water and they are creating islands. An example of a mid-oceanic ridge is a mid-Atlantic ridge. The ridge is so tall that it actually rises above the sea in many places, forming volcanic islands. Iceland, one of the world's largest islands, sits on the northern crest of the mid-Atlantic range in the North Atlantic Ocean. In any volcanic eruption, magma rises from the depth of the earth to the surface of the land or the sea floor. But underwater, the magma still faces the crushing pressure of tons and tons of ocean water once it reaches the sea floor. The boundaries allow superheated molten rock called magma, along with ash and gases, to rise through Earth's crust and emerge on the surface, often dramatically. Since many plate boundaries are submerged, around three-quarters of all volcanic activity on Earth actually occurs underwater. And they erupt at a depth of around 2,200 meters below sea level. On page number 16, the second type is volcanism at destructive plate boundary. Let me explain from your book, page number 16. Volcanism at destructive plate boundaries takes place when an oceanic plate subducts beneath a continental plate to melt into the mantle. Now here they say that an oceanic plate subducts beneath a continental plate. So this is again a plate boundary where one plate is oceanic plate and the other is continental plate, and they subducts. You know what is subduction? Subduction is a geological process that takes place at convergent boundaries of tectonic plates. where one plate moves under another and is forced to sink due to high gravitational potential energy into the mantle. The regions where this process occurs are known as the subduction zones. So here, an oceanic plate subducts beneath the continental plate, and I've told you the gravitational potential of the mantle makes it melt into the mantle. At the same subduction zone, magma may erupt onto the Earth's surface as lava. Repeated eruptions of lava through these cracks over time build up layers upon layers of volcanic materials to form a cone-shaped mountain-like feature called a volcano. So on page number 16, then there is a figure 2.12, which shows the structure of a volcano. And you can see that there are different parts of the volcano. Let me explain all the parts one by one. The first part is vent. You can see even in figure 2.12. The vent is the opening or a hole in the Earth's crust through which the magma comes to the Earth's surface. You can see that this is an opening on the Earth's crust from where the magma is um, forced to forced on the Earth's surface, and is the opening from which lava flows. The dust, ash, and rock particles can also be thrown out of the vent. The second part is cone. You can see even in the figure when the lava is coming out from the cracks, it is making layers upon layers of volcanic material, the materials that built up around the vent to form a cone-shaped structure. So this is called cone just because of the shape of this structure. The third part is pipe, and this is actually the passageway which joins the vent to the crater. Crater is the top side of the pipe, and vent is the bottom side of the pipe. So the pipe joins the vent to the crater of the volcano. It allows the magma to flow from the vent to the crater. The next part is crater. And you know what crater is? This is approximately circular type of depression in the surface of the earth. And this is the top of the pipe through which magma is forced onto the earth's surface. So the next part is lava. And you know that the magma which is forced onto the earth's surface, this is called lava. This is the molten rock that has been expelled from the mantle. And the last part is the magma chamber. Magma chamber is at the bottom of the volcano. The magma chamber is very hot that can melt the rocks to make lava. This is situated in the earth crust, and this is here to hold the magma. On page number 17, there's a third type of volcanism, which is volcanism at hotspot. And volcanism at hotspots takes place when columns of molten magma in the mantle rises from the hotspot to the Earth's surface. Hotspot is a fixed spot inside the Earth and melting the crustal plate directly above it. These rising columns of magma are found in fixed location deep into the mantle. The volcano that forms from the column of magma is called a hotspot volcano. Hotspot volcanisms are like isolated areas of volcanic activity that are not associated with plate boundaries. These volcanoes are found both on continents and out in the ocean. So there are three diagrams in your book on page number 17, figure 2.13. They're showing you volcano A, volcano B, and volcano C. I'm trying to explain all these three diagrams in this single diagram. You can see that here is a volcano that is formed here. The volcano that forms from the column of magma is called a hotspot. So this is, we can say, like the area, this is the hotspot of the mantle. This is the fixed hotspot that is not moving from its place. Over the time, the underwater volcano increases in height to come out of the ocean surface to form islands. Just like this, you can see they are coming out from the ocean floor. This is the ocean floor, and this is coming out, and this is now making island here. So this is an island now. Do you know that this crustal plate, this is the crustal plate, this is the ocean floor, and this is the crustal plate. You know that this crustal plate is constantly moving. This is constantly moving slowly and gradually. It carries, like this was the first, we can say the first volcano that even made an island here, and it moves with the earth crust when it carries along the volcano, which becomes extinct while a new volcano forms over the original hotspot. So that was, we can say, the oldest island which was extinct. It was the oldest volcano that moved with this, the movement with the earth crust, and that was the second, the third, the fourth, and this was the new, and it will move with this earth crust, and the hot spot will remain here, and it will make more and more volcanoes. This results in a chain of volcanic islands being formed.
A hotspot is a localized source of high heat energy that sustains volcanism. It is not an isolated shallow magma reservoir beneath the crust, nor is it a pipe of magma that streams from the outer core. One theory holds that hotspots may begin as a blowtorch-like thermal perturbation in a zone between the liquid outer core and overlying mantle about 2,900 kilometers deep. The thermal plume allows solid, yet mobile mantle to rise very slowly and convect outward. Convection is the process by which heated material rises and cooler material sinks. Although magma may be generated as deep as 1,500 kilometers, individual blobs do not traverse the entire mantle. Let's zoom in to look at the onset of hotspot volcanism beneath a moving plate. As each pocket of melt stalls, its heat is transferred to adjacent rock. This transfer continues to the base of the tectonic plate, where decreased pressure facilitates rock melting. The magma that forms at the base of this plate rises through the plate in a network of cracks and shallow chambers and erupts on the surface. Over hundreds of thousands of years, large volcanoes build on top of the plate. The weight of the volcanoes bends the plate downward. Volcanoes that spent their constructive life over the thermal plume slowly get rafted away on the moving plate, and new volcanoes build in their place. Multiple dikes can feed several volcanoes from separate conduits. The moving plate drags the thermal plume with it. This can explain why volcanoes can erupt again after centuries of quiescence, even after they have moved off the center of the hotspot. However, erosion greatly outpaces volcanism as eruptions wane, and the buoyant effect of the plume diminishes, allowing the volcano to subside.
So dear students, that was all about about today's lecture, and here I'm going to give you an assignment. You have to do two questions today. Do these two questions in your book, in your notebook, and make a margin line. Write your date and today's date, date and date, and do this work neatly. The question is, what is volcanism? And the answer is, volcanism is the phenomenon of eruption of molten rock onto the surface of the earth. It refers to the processes by which materials such as magma and gases from inside the earth are forced onto the earth's surface. This is your first question. The second question is a bit lengthy, and this is about the types of the volcanism. So explain the types of the volcanism. Uh, we just we are just done with the three types of volcanisms here. There are three types of volcanisms. The first one is underwater volcanism. When oceanic plates move apart, leave a gap between, leaving a gap between the plates, allowing magma from the mantle to surface through the gap as lava. When the lava comes into contact with seawater, it cools and hardens to form crust on the ocean floor. The magma is sometimes ejected with some pressure, causing it to spew upwards to form a ridge. The world's underwater ridges and volcanic islands were formed as a result of underwater volcanism. The second type is volcanism at destructive plate boundary. You have to give this heading and then write the details. It happens when an oceanic plate subducts beneath a continental plate to melt into the mantle. Magma may erupt onto the Earth's surface as lava. And then the third type is volcanism at hotspots. Volcanism at hotspots takes place when columns of molten magma in the mantle rises from the hotspot to the Earth's surface, melting the crustal plates directly above it. These magmas are found in fixed positions deep within the mantle. The volcano that forms from the column of magma is called a hotspot volcano. With time, the volcano increases in height to rise above the ocean surface to form islands. As the crustal plate is constantly moving, it carries along the volcano, which becomes extinct while a new volcano forms over the original hotspot. Thank you so much for watching this video. I hope you must have enjoyed today's lecture. We'll meet up again. Till then, bye.